canine science teacher. I'm here to help you be a Sci fanatic. Our lesson for today is about the mole concept, and these are our learning objectives. Differentiate the molecular unit from formula unit and compute for the molecular mass. Define mole and calculate the number of moles of given compounds. Compute for the number of particles given the mass or the number of moles. And convert the number of moles, mass, and the number of particles from one unknown to another. The counting units are often used to easily represent the number of items. It is more convenient to represent this as a collective counting words than counting them individually. For example, we use the term a pair of slippers. How many pieces are there? Okay, there are 2 pieces. When we say a dozen of eggs, there are 12 pieces. When we say a gross of pencils, there are 144 pieces. And lastly, when we say a ream of paper, there are 500 pieces. Atoms are incredibly small. It is impossible to count the number of atoms or molecules to get their mass. What counting unit do we use to represent the number of atoms? If your answer is small, you are correct. The formula mass and molecular mass are 2 values that express the size of a molecule. Let's differentiate molecular mass from formula mass. The formula mass is the sum average of the atomic weights of the atoms in its empirical formula. We use AMU or atomic mass unit as their unit. For molecular mass of a molecule, it is the average mass as calculated by adding the atomic weights of the atoms in the molecular formula. We use the unit gram per mole for molecular mass. Now let's go to the steps in calculating the molecular and formula mass. So I have here 3 basic steps, so I want you to take note of the following steps. First step is to determine the number of atoms of the elements present in the molecule. Second step is find the atomic mass of each atom using your periodic table of elements. Multiply the atomic mass to the number of atoms of the elements present in the molecule. And the third step, get the sum of all the product. Now let's have a sample problem. Mefenamic acid consists of C13H18O2. It is a common compound that is mostly used in pain medication. What is the molecular mass of this compound? First step is to identify the different elements. We have carbon, hydrogen, and oxygen. Next is to identify the number of atoms present in the compound. For carbon, we have 13, for hydrogen, 18, and oxygen is 2. Then, grab your periodic table and get the atomic mass. So for carbon, that is 12.01, hydrogen 1.01, and oxygen is 16. You multiply the number of atoms with the average atomic mass. After that, after getting the product, get all the sum. So the molecular mass of mefenamic acid is 206.31 grams per mole. Now let's have another example. Compute the formula mass of lime water. So the elements present in the compound are calcium, hydrogen, and oxygen. Again, get the number of atoms, get the average atomic mass, get its product, and get the sum. So, the formula mass of lime water is 74.10 AMU. In chemistry, Mole is simply defined as the quantity of a substance that contains the same number of particles. For example, 1 mole of table salt or NaCl is equal to 6.02 times 10 to the 23rd power of NaCl ion. Next is 1 mole of water is equal to 6.02 times 10 raised to the 23rd power water molecules. Also, 1 mole of sugar is equal to again to 6.02 times 10 raised to the 23rd power of sugar. Lastly, 1 mole of gold is also equal to 6.02 times 10 raised to the 23rd power gold atoms. It is also important to note that 1 mole is the amount of substance that contains as many particles as there are present in 12 grams of carbon-12 atom. The actual number of atoms in 12 gram of carbon-12 isotope is equal to 6.02 times 10 raised to the 23rd power particles called the Avogadro's number, in honor of the Italian scientist Amedeo Avogadro. So always remember that 1 mole of a carbon-12 atom is equal to 12 grams of carbon atom is also equal to 6.02 times 10 raised to the 23rd power of carbon atom. The counting unit for atoms, ions, and molecules is the mole, which is also equivalent to its molecular mass, the formula mass, and also equivalent to the molar mass, and also equivalent to the Avogadro's number. Take note of the following equivalents. Here's a little bit of trivia. Did you know that 1 mole of a substance contains 602 hexillion particles? That's a lot. No one can actually count the number of atoms, but if you can, it will take 20 quadrillion years to count them all. Before we proceed to our computation, I want you to grab your periodic table of elements, your calculator, your pen and paper, and bring with you a lot of patience. Let's now calculate the number of mole given the mass or vice versa. Operationally, the number of moles is determined using the formula mole is equal to mass in grams divided by the formula mass or the molecular mass. So let us calculate the number of moles of oxygen in 24 grams of O2. From the definition of a mole, we know that 1 mole of O2 is equal to 32 grams. So let's substitute the values to the formula. 24 grams times 1 mole divided by 32, cancel out the common units, and the answer is 0.75 mole of oxygen. Another way of solving this problem is by using a conversion factor. We know that 1 mole is equal to molar mass, so we can use this concept. First thing is to write the given, which is 24 grams of oxygen. Then, multiply it by our conversion factor. Take note that the unit of the denominator is the same as the unit of the given. The unit of the numerator is the same as the one that we're looking for. Then, we can cancel out common units, which is grams. Then, multiply 24 times 1 mole. The answer is 24 moles divided by 32. And the final answer would be 0.75 mole. Let's calculate mole-mass relationship. The problem is, what is the mass in grams of 2 moles of magnesium? First step is to get the given. You have 2 moles of magnesium, and also get the atomic mass of magnesium using your periodic table, which is 24 grams of magnesium. Next is to find what is the unknown, and that is the mass in grams of magnesium. So the relationship is from mole to mass. So the equivalent is 1 mole is equal to 24 grams. For your solution, so 2 moles of magnesium times 24 grams of magnesium divided by 1 mole of magnesium. So cancel out the common units, then multiply 2 and 24, we will have 48 grams of magnesium. Let's have another example. What is the number of moles of 36 grams of water? The given are 36 grams of water. Also, you need to get the molecular mass of water, which is 18 grams per mole. And the unknown is the number of moles of water. So from mass in grams, you need to convert it to moles. 18 grams is equal to 1 mole. Always remember that. For our solution, 36 grams of water times 1 mole of magnesium divided by 18 grams of water. So 36 times 1 is 36 divided by 18. The answer would be 2 moles of H2O. Now let's try to calculate mole and the number of particles. The problem is, carbon dioxide is a byproduct of respiration of humans and animals. It is used by plants to perform photosynthesis. If a human released 3 moles of carbon dioxide in a second, how many molecules of carbon dioxide are there? So next is to get the given, which is 3 moles of carbon dioxide, and then try to get what is the unknown, and that is the number of molecules of carbon dioxide. So our conversion is from the number of moles to the number of molecules. For our solution, 3 moles of carbon dioxide times 6.02 times 10 raised to the 23rd power of molecules divided by 1 mole of carbon dioxide. So 3 times 6.02 is 18.06. Take note, class, that you need 1 decimal place only, so we need to move 1 decimal place going to the left, so it will become 1.8 times 10. So you move 1 decimal point, so you add 1 on your exponent, so it will become 24 molecules of carbon dioxide. Remember that the relationship between 1 mole of any molecule is always equal to 6.02 times 10 raised to the 23rd power of molecules, and vice versa with molar mass. The conversion factor may be written in 2 ways. 1 mole divided by 6.02 times 10 raised to the 23rd power of molecules, or 6.02 times 10 raised to the 23rd power of molecules divided by 1 mole. Let us do some dimensional analysis to practice your skills and apply what you have learned about mole and the number of particles relationship. Remember that 6.02 times 10 raised to the 23rd power particles is equal to 1 mole. I want you to convert the following units, write your solution, and answer on a separate sheet of paper. You can pause the video while doing your computation. For question number 1, what is the number of particles in 0.500 mole of aluminum? Okay, for our solution, first thing is to write your given, then multiply it by the conversion factor, then cancel out common units, and then you can proceed with multiplying 0.500 to 6.02 times 10 raised to the 23rd power particles. And the answer would be 3.01 times 10 raised to the 23rd particles. I hope you got this all correct. For our second problem, what is the number of moles of sulfur in 1.8 times 10 raised to the 23rd power of sulfur atoms? For our solution, again, write your given, multiply it by the conversion factor, cancel out common units, and then multiply 1.8 with 1 mole. And the answer is 1.8. Divided by 6.02, the answer would be 0.30 mole. For number 3, how many moles is 25.2 grams of iron? For our solution, first, again, copy your given, multiply it by the conversion factor. Cancel out common units, and then multiply 25.2 with 1 mole and divide it with 56, and the answer will be 0.45 mole. Here's a simple conversion guide for you to follow. So remember, if you want to convert number of atoms or molecules to moles, you just need to divide it by 6.02 times 10 raised to the 23rd power. And from the number of moles going to the number of particles or atoms, you need to multiply it by 6.02 times 10 raised to the 23rd power. When you're going to convert from moles to mass, you need to multiply them by its formula mass. And from mass to mole, you need to divide it by its formula mass. Thanks for watching. I hope you had a fantastic